Okay, so don't worry too much about this seating chart. We're in the mask requirement updates. That's from last semester. But you will see in these, one's down here, we're going to be working a lot on three-phase transformer banks in ELW 112. So there's three ways that we work on this. One, you're going to have to produce a drawing of an open delta bank, a Y bank, and a closed delta bank. You're going to have to do it on what we call a transformer simulator set, which we've got two of those. We can actually do those out of the field. We just plug them in out the field, and you wire it up on a simulator, and it actually shows you output voltages and everything like that. And then we actually going to put three transformers on a pole, and you're able to wire it up just like you would in real life. So that is the meat and potatoes of ELW 112. If you click on the different pictures that we have in here in ELW 112, let's see. This is the wiring diagrams that you're going to be looking at. And there are probably is about 16 different types of three-phase transformer banks. We're going to use the most popular three. That's an open delta, closed delta, and a Y bank. And if you'll notice, let's see if we're able to do this a little bit, and that's a little small for you guys. We're going to give you a template that has these four lines on top, A, B, C, N, and the four lines on the bottom, A, B, C, N. And then we're going to ask you to draw an open delta bank. And essentially you do everything that's not included with these four lines. You draw in your voltages. We give you those voltage numbers. You just draw the lines. You'll notice here, A to neutral, 7200, B to neutral, 7200, C to neutral, 7200. And then all your phase-to-phase voltages, 12470, 12470, and 12470. So AB, BC, AC are all 12470. You notice over here also, what do we do to the neutral in a Y configured system? What am I hovering around right here?
Grounded.
Yeah, it's a grounded system, so you got to include your ground in that also. So, you know, like us, we try to teach you tips of the trade here. How many transformers are in an open delta bank?
Like two.
Like two, yeah. If you're looking at it, this is it. So you got an open delta bank here. You've got two different transformers. We'll talk the wiring processes a little bit later on when we get together, but that's just a helper. So that's open delta. And like I say, you can study, these are great to study right here, because what's going to happen is we're going to be giving you this. That's what you're going to get. So that's going to be one of your quizzes right there. This is all you're going to get. Draw a Y bank, include primary and secondary voltages phase to phase and phase to ground. Do the transformer secondary windings need to be changed? We'll discuss what that's about here in just a moment. We give you the voltages. So when I say 2400 to 4160, the 2400 is what? Phase to
neutral.
Right, and the 4160 is
phase to phase.
Phase to phase, correct. All right. There he is. Good morning, sunshine. Harry Chin made it. And on the secondary side, yeah, the secondary side, your voltages are 277 and 480. So that's simply put phase to ground, A to neutral 277, B to neutral 277, C to neutral 277. Then your phase to phases are A to B, 480, B to C, 480, A to C, 480. Don't worry, we will give you plenty of practice sheets to practice these on. It's not like a give and go type thing before you're going to be doing that. So in a Y bank, and here, let's get out of this one.
So we're going to have to draw this out or write it out?
We'll draw and write.
Okay.
So what, let's see. Show you, I just showed you the Y in that configuration. And it doesn't, you know, we're not artists. So you remember the template I had, we just had the letters, right? You have to draw in 3 transformers, and you have to draw in all these lines. The 7200 line, you have to draw in the bushing line to A, the bushing line to B, the bushing line to C. Then all 3 of these are tied together and they go to ground. Then this one goes to, it is grounded neutral. On your secondary side, which we supply the voltages, so you'll be able to throw these numbers in. It's just, you don't have to look them up from nowhere. This is 120, 208. So 120 from A to N is 120, B to N to 120, C to N 120, and phase to phase is 208, 208, and 208. But you have to draw all these lines in, and we'll get to that hopefully today in the process of how to do that. Like I said, difficult online, but I can tell you one thing. If you study these attachments, even if you trace it, get a piece of paper, print these out, or whatever you want to do, we'll do when we get in class. Trace over the top of these things and just get the line business down. We'll be able to knock it out. So keep the share going on here. So some general rules that are going on. Let me go back here. Okay. And these are very, very good videos right here. And we're probably going to try to show one here in just a minute to everybody online. These Chalk Talk, it's called Chalk Talk 3-phase banks. Now, all the configurations that we're going to use as far as we're concerned is Y. Y primary, then we can go Y secondary, closed delta secondary, and open delta secondary. So all of our templates that we're showing in there are Y primary. Everybody understand that?
Yeah.
Say if you don't, it's okay.
I think I got the concept.
Okay. Chalk Talk has got them all. So if you see, bring this up. All right, I'm not going to start playing right here because it's not one I really want. What does it say on top? Open delta to what?
Open delta.
Open delta.
Yeah, we're not using that. We use Y to open delta, or Y to close delta, or Y to Y. So these are the wrong videos. I don't want you to watch these. Open delta and delta systems, as far as primary are concerned, are almost non-existent. They're out there for teaching purposes, but most of your electrical utilities are working on a Y distribution system. When I say Y distribution, that's everything that comes out of the substation is Y. What does transmission transmit at? Delta or Y? No neutral. Transmission. Delta or Y?
Delta.
Delta. There you go. And there's a reason behind that. So let's do this here real quick, just to give you guys a, let's see, Chalk Talk. Let's see. And I might, you know what I might do here is I might unshare so you get, hold on a second, stop share. Let me share screen again. Share sound and optimize for video clip. Desktop. Okay, so let me know when that share is back.
It's back.
Can everybody see that? Okay. Chalk talk Y open delta. So I specified Y is my primary, then open delta is my secondary. I'm just gonna do a search on it. There you go. Open Y, open delta, not really. Open Y, Y delta, open delta, open delta. This is the one we're gonna use right here. Why did they say open Y? Any guesses? How many phases am I using out of 3 phases?
Like 2.
2. So that's why they're saying open Y. I'm not using all 3 of the Y primary phases. So let's go into this. This is going to be a trial and error type thing. Let me know if you can hear the volume.
All right, let's talk about an open Y, open delta.
Oh, yeah.
Okay, great. So I'm probably going to pause this several times. I'm going to turn it up just a little bit. Can everybody hear it okay?
It's kind of blurry looking.
It will be because and I'll post the links in Discord so you guys can go back to these.
All right, let's talk about an open Y, open delta connection. So let's start on our primary side. And the first thing with this open Y primary connection is take your H2 bushings, you tie them together, and then tie it to ground.
Okay. So in 3-phase transformer banking, what you have to do here is you'll notice you got an H1 bushing and an H2 bushing on each transformer. You can use either one, but you have to use the same on both transformers. So if I wanted to carry my primary voltage from B and C to H2, I'd have to use both H2s. Then H1 would be grounded. Or, like he's drawing it here, he's going to ground both H2s and use both H1s for primary. Does that make sense?
Yeah.
Yeah. You can't mix and match. Whatever bushing you use as the energized bushing on the transformer, it has to stay the same between all 3 transformers. Does that make it look any better?
Yeah, a little bit.
Okay.
Now with the H1 bushings, you only need to utilize 2 phases. So let's just utilize, we're going to go to B phase and to C phase. And it really doesn't matter. It just depends on what your engineering department wants whichever phases they want you to use. So you could just as easily go to A phase instead of B phase here.
Okay. You can use A and B. You can use B and C like he's doing here, or you can use A and C. Doesn't matter, just as long as you use 2.
It doesn't matter. Just depends on what they're looking for. So this is the primary Y connection. Your H2 bushings are tied together and then tied to ground, and then you utilize just 2 of the phases. We use C phase and B phase. And that's our primary connection. Okay, let's move on to the secondary connection. So on the secondary side, we're only going to utilize 1 X2 bushing as our neutral. So we're going to take it to ground, and we're going to do it on the center transformer. Labeled as our neutral. So there's our neutral. Now what we need to do is I need to tie the X1 bushing to the X3 bushing. Once you've done that, now we can just run our hot legs down. Off the center phase is going to be our hot legs. And you got your 2 hot legs. I'll label them H. Your hot legs are going to be off the transformer that the neutral is used on. So since we grounded the X2 and our neutrals on the center transformer, this is where our hot legs are going to be. This other connection right over here off this transformer, this is going to be your power leg.
Okay. He gives that explanation right here. In an open delta, everything that you see in the field, as far as it facing it. So we're actually facing towards the two transformers themselves. The left transformer, write this down in your notes, is your lighting transformer, L-I-G-H-T-I-N-G, not lightning, lighting. And the transformer on the right-hand side, he calls a power transformer. Professor V calls it a power transformer also. I call it a high leg transformer. Okay. Everybody still
Said
got
lighting, and what?
lighting. Yeah. Lighting and power.
Okay.
All right. They're in the same location every time facing the transformers. Lighting's on your left, power or high leg, either one, they both mean the same thing, is on your right-hand side. Lighting is named for such is, this is, if I took the high leg transformer away, or this transformer on the right away, this is the same kind of transformer that would light your house. It's 120, 240, or whatever the voltage of the transformer is. But I've got single phase power right here. So that's why they call it lighting. And you got your high leg transformer on the right here. And that gives you your fourth leg, 1, 2, 3, fourth leg for three-phase power. All right, let's get a little some descriptions going on here so you know what these different wires are called. Does anybody remember what the wire from the bottom of the switch to the transformer is from the primary? I'll take that as a no. That is the low side riser. Put that down in your notes. The wire from the bottom of the switch to the bushing of the transformer is the low side riser. You'll hear some companies say it's the low side stinger. Okay.
Real fast, what was the right transformer called one more time?
It's either power or high leg. Yeah, you guys know what it is, just jump right on in there.
The wire from the switch to the bushing is called what again? I'm sorry.
The low side riser. It's kind of contradiction in terms, but that's what it's called. Low side riser or low side stinger, like the stinger on a stingray.
Gotcha.
Okay. Where he's got them connected right there, right where your mouse is at, just about right below that. Mm-hmm. He said from X3 to X1.
Bushings on your transformers. Can you see my mouse hovering?
Yeah, but it's just real blurry on the.
I understood. I'm going to just call it out to you. Okay. They're numbered in order: X3, X2,
okay,
X1. Okay.
Right.
Your next transformer over X3, X2, X1. Sorry for the blurriness. And like I said, I'll post these videos so you can watch them directly, much clearer. Okay. The wires coming out of the transformer down, don't laugh at this, are called jug leads. J-U-G. Jug leads. So the wires coming down, jug leads, and they're made out of copper. So you have a real good conductor right there. Right? And the wire going from transformer to transformer bushing, I'm coming out of this X1 bushing and I'm going to the X3 bushing of this transformer. It's called a tie-in bus. T-I-E-I-N-B-U-S, tie-in bus.
That's the one from transformer to transformer?
Yes, sir. Gotcha. Whatever goes between transformers is the tie-in bus.
And those are called terminals. Those are terminals? X1, X2, X3?
I call them secondary lugs.
Lugs?
Yeah, secondary. Primary voltage in the top, transformed, and then secondary out. Secondary lugs.
Oh, I got you.
Okay. Okay, so I'm going in with a primary voltage. Transformation is happening inside the transformer. Then my secondary voltages are coming out the front here. Okay, so let's proceed on.
It's your power leg because it's 1.5 coils from the neutral. So we got one full secondary coil there, and then another half of a secondary coil there. So it's 1.5 coils away from the neutral. That's how you know which one is your power leg. The reason why that's important is predominantly an open bank is used where you have a single phase load, that's the primary load, but then you also need some three-phase power. That single phase load, which usually is like a home, you want to make sure and use the 2 hot legs in the neutral for that home. You do not want to run the power leg to the home because then you'll be sending too much voltage into the home and you could burn up the electronics, like TVs, computers, things of that sort. So you want to make sure that you identify what your power leg is and only use the power leg for the 3-phase load. For the single phase load, you want to utilize your 2 hot legs in the neutral. One thing with an open bank, it's 50.
So you understand what he's saying there? I can actually have, say I'm on this side of the street and I've got a couple homes over here. I can power those 2 homes with just this transformer by itself. All I need is these 2 hot legs in the neutral. But say across the street, I've got a little store that's got some 3-phase air conditioners. I can pull some secondary across the street to them, and I could power those couple of stores or even the one store for 3-phase off the same bank if I use the power leg. So you can use it for multi-purpose right here. 2 services go to the left, feed 2 homes. 1 service goes to the right, feeds a 3-phase motor over here. You can feed them all from one spot.
Because houses aren't 3-phase?
Not anymore. They used to be. That is a good question. Back in the 60s and early 70s, I don't know if you guys are aware of like areas like Pine Lakes and the old parts of Myrtle Beach up there. A lot of homes, the bigger homes up there did have 3-phase air conditioners. And there was a lot of open delta up there in those areas. That's because back in the old days of air conditioning, it was just the norm. It was the norm to have 3-phase air conditioning. Well, single-phase air conditioning came along, became much more efficient. And now 3-phase air conditioning for a single home is just not used as much anymore. Does anybody know where Oliver's is up there in Red Hill?
Yeah.
Yeah, it's a perfect example right there. Oliver's is pretty much an all-electric single-phase place, but he's got 1 air conditioning unit in there. That thing is huge. He keeps that place about 68 degrees in the summertime. So all he needs is just 1 run of 3-phase to power that air conditioner. And you'll notice if you drive by there, look at the pole that's outside the complex, there's an open delta bank just to power his air conditioner out there. Okay.
And he said power leg is 1.5 coils away from what?
It's 1.5 coils away from X1. So you got 1.5, 1 full coil and a half. We're going to jump back to our drawings here in just a minute after we do this, and we'll show you how to compute that as far as numbers are. It's a little bit of a head scratcher, but we'll work on it.
57.7% is efficient as a closed bank where you have 3 transformers. But it is very useful when you have a load where it's predominantly a single-phase load, but you also need a 3-phase load. Now this particular connection right here, if you look, we've got the H2 bushings connected together, and then on the bottom side, we've got the X1 is connected to the X3. So this type of connection in this open Y open delta bank, it's called the same,
but different.
The same opposite connection.
That's confusing. Don't worry about that.
Let's see if I can get it to right here.
You don't need to know that. It's going too far deep into what you need to know. Okay, so we've looked at open delta. We actually saw him draw it in and how it goes on the actual back. I'm going to run back here to the drawing that we have. And here it is more in a schematic setting. Okay.
So is this picture different than the other two?
Yeah.
Because I'm screenshotting them. All right.
Well, it's in your D2L.
Okay.
If you want to log into your D2L ELW 112, you can download them right to your PC or phone, whatever you like to do. Okay. So what they've done here is we went in and added the voltage values. So they're saying here, this is a 120, 240 volt open delta bank. Don't worry about transformer codes. That's different types. And I'm using two 240 volt transformers. That's 120, 240. What's my primary voltage phase to ground?
7,200 volts.
Correct. And phase to phase?
1247, 12,470.
Correct. Great, Aaron. And the reason why we're not 7,200 times 2 is we're using the 1.7325 number, correct?
Right.
Right. That's our computation. So I've got A phase feeding H1, B phase feeding H1 on the next transformer. I've tied in both H2s to neutral, and I've grounded it over here. Then my secondary is just like it was before, X3, X2, X1, X3, X2, X1. I come down, and this helps me out. I always draw in X2 first, and I take it down to neutral. And the neutral down here is grounded also. Then I'll do in my hot legs. Now, you'll notice in this picture, they did it a little bit different. Electrically, it still works. They went into the tie-in bus right here that goes from transformer to transformer, made a connection, and came down. If you draw this where you just come down from X1 and then go straight across, that's electrically sound also. That will also work. And I like the way they keep this in order. X3 goes to where?
A.
Right. X1 goes to
B.
And X1 of the next transformer goes to
C.
C. So they do alphabetically, A, B, C. Then X2 comes down to the neutral here. Like I said, we drew in this first to make sure we took care of neutral. So try to keep things in order. Now, can I use any two phases that I want to on the primary?
Yes.
Can I go B?
Yeah.
Yeah. Use any two that you like, but they're kind of smart here. A, B. Follow the alphabet. Now let's take a look here at our voltages. This is where it gets kind of funky here for just a moment. My A phase, hovering over the dot here to neutral, is 120 volts. That's how much voltage I'm getting out of this X3 leg. My B phase, which is this wire, or if it came out of X1, would come right down to here, is 120 volts. Now, Aaron, you said this a moment ago. I've got a winding and 1/2, correct?
Yeah.
All right. My C phase, which is on the next transformer, is what?
240.
208.
208. My bad. I can't see that.
I understood. It's kind of, I know it's a little bit blurry under it. It's 208. Why is it 208?
Because it's 1.732, isn't it?
Exactly. Good catch right there. Remember, what happens in primary, I'm using two different primary phases, happens in secondary. So if I got 120 out of this transformer and 120 out of a different phased transformer, this is A, This is B. I can't add 120 and 120 together. I'm using a different primary phase. If I start using a different primary phase for the second transformer, it's whatever the phase to ground voltage is, 120 times 1.7325. So I'll make a test here on everybody. We'll take a break here in just a moment. I'm going to say these are two 480 transformers. Phase to ground here is 277, 277. What is C to N? If my phase to ground is 277 and 277, what is C to N?
It would be.
Somebody tell me the math. Tell me the math I need to use.
It would be 277 times 1.732, right?
Right, 25.
1.7325.
Yeah, times 277.
Like 479.
Anybody else?
4.79. I mean 479.9. So 480.
There you go. There you go. There you go. So that's open delta. And like I said, we'll have plenty of chances, when we get back in the classroom to draw these things out. This is just to get you up to speed here of open delta, closed delta, and Y. So stop that share. I am going to pause the recording here.
This meeting is being recorded.
All right, so we're going to return here. All right, so I'm going to jump back to the ELW 112 homepage. We just went over open delta. That's the picture that we've shown you before. We're going to jump into Y. Excuse me, that's wrong. Closed delta next. All right, so how many transformers are in a closed delta bank?
Like 3.
3, right. So open delta is the only transformer bank that has 2 transformers. Closed delta and Y banks have 3 transformers. Now it's a pretty strange thing to see right here. I don't know how you guys are looking at your screens, but if you take your hand, and this is what I'm doing, I'm going to cover up the left-hand transformer completely with my hand, and I'm only going to show 2 transformers. Well, guess what kind of bank that is?
And everything's the same as the last one.
Right. So all we need to do here on closed delta is what they call closing the delta. Instead of open delta, I'm going to add the 3rd transformer to the left-hand side. Wiring's a little bit different, but that's all I'm going to do. So I really recommend when you guys are doing this in the classroom environment is go ahead and draw the closed delta first. Open delta is the easiest to explain to start off with as far as wiring and everything like that. But if you draw the closed delta first, then get another sheet of paper and erase the left-hand transformer, you got an open delta bank. Simple as that. All right. So we're going to come up here at the top. Once again, we supply you with the voltages. You have to draw those in when you get your blank sheets. Again, they're using 7,200 volts, phase to neutral, and 12,470 phase to phase. I like the way they do it. This is the way it keeps my mind right too. They go left to right, ABC. So my left transformer to H1 is A. My center one is to B. Center transformer H1 is to B. And my right-hand transformer is to C. They do something different here, and it is required of a closed delta bank. My H2 goes from H2 to H2 to H2, where does it not go?
It doesn't go to.
It does not go to the neutral, right? That's because this is closed delta. So in your notes right here, whatever you want to draw on, that right there, that wiring configuration for all the H2 bushings is called a floating neutral.
And this is open Y to closed delta?
Nope, closed Y, 1, 2, 3, using all three to close delta.
You said floating neutral?
Floating neutral, correct. All H2 bushings. This is the only bank it happens on. On a closed delta bank, 120, 240 closed delta bank, this is the only one that has a floating neutral. The floating neutral does not connect to our system neutral up here. All right. Let's go ahead and start. I like to start with the center transformer. What do we call this? Lighting or power?
Lighting.
Lighting.
Lighting. Now, in open delta, this is our power transformer. We're adding another power transformer. Both of these transformers are going to be a power transformer or high leg. So I'll start in the center
right.
Left and right.
Okay.
Okay.
So if there's just two transformers, the left one's always going to be lighting, but if there's three, the middle one's always going to be lighting.
Correct.
Gotcha.
Good deduction there. All right. On this drawing, I like to start in the center. Now, oh my goodness. Hold on, Robbie's destroying my phone. Yeah, his temperature's back up, guys.
Okay.
So left and right are power.
Yeah.
In the middle, lighting.
Correct. So this can get kind of confusing, and I'll be just totally 100% honest here. I don't like the way this is drawn. You can draw it this way. It is 100% electrically good, correct. But I like to do this a little bit differently. What I will do here on my lighting transformer is just like I did before on open delta. I will take X3 to A, X1 to B, and both of the power transformers I will take to C. It just keeps my mind in order. But to not confuse you guys, and I know we could probably sit on this for a couple hours and get everybody's mind screwed up on it. We'll follow what the drawing says, and we'll actually, let's watch the video too and see what the video does also. So what they're doing for the lighting transformer here, he takes X3, or they take X3 to B, they take X1 to C, and they take both power transformers, the outside lug, both X1 and X3, to which phase?
A.
A. Okay. Open delta, to give you a little description here, I gave you Oliver's before as an open delta situation. Most of the inside is just lights. I think he uses electric grills in there. That's 120, 240. And that AC unit was the only thing three-phase he had running in the place. And it's a real big unit. So a little bit of three-phase, a lot of single-phase power that he needed. Closed delta goes more to, who knows where CAM4 is at?
Where?
CAM4, the wood processing, the lumber plant.
Right there in Conway?
Yeah.
On Cox Ferry?
Yeah.
Yeah.
Yeah. Well, what's inside the lumber plant? What is the majority of the load that's inside that lumber plant? What do they got to do to the wood?
Cut it.
What do you do to a tree to make lumber?
Cut it down.
You got to saw it, right? So they've got tons and tons of three-phase motors in there running saws. They need more three-phase power. So closed delta is more apt for them to use in that kind of environment. They need the power of the lighting transformer and a lot of three-phase power. So they're going to add the third transformer in there to suit their needs. All right, follows the same rule here. We start at the top, A, B, C, H1, H1, H1. H2, H2, H2 are all tied together, but we do not connect them to the system neutral. That is called a floating neutral. X3 to B, X1 to C. The outside transformer bushing on both of the power transformers go to A. Now we moved some things around in here compared to the open delta. Before, C was my power leg, right, on open delta. That's where I had the 208 reading. Where is it at now?
A to neutral.
A to neutral is now my power leg because that's where I have it connected here and here. So we've moved the high leg voltage reading to where it belongs as far as their wiring is concerned. B that comes off the lighting transformer is still 120, and C coming off the lighting transformer is still 120. Phase-to-phase voltages are all 240, 240, and 240. Okay, questions here? And we'll go to the video here in just a moment. Okay. All right, chalk talk. Make this big.
Okay, so let's do a Y delta connection. We'll start with the Y primary side. So first thing we need to do is we need to take all our H2 bushings, connect them together. Once they're connected together, we're not going to tie it to ground. So a common saying with a Y delta connection is Y delta you float, meaning that the H2 bushings are connected together, but they're not tied to ground. So Y.
Okay, well, once again, that's the reason why we call that a floating neutral. It's not connected to the system neutral.
Y delta you float. Now each H1 bushing is just going to go up to a phase. Take this H1 over to C phase. So we've got our H1s going to each phase, A, B, and C phase, and our H2s are connected together, but not to ground. That's our primary Y connection. Let's go ahead and move on to the secondary side. So for our secondary connection, we're only going to utilize one of the X2 bushings as our neutral. So we're going to take the center one down to ground, and this X2 bushing will be our neutral. The other two, the two other X2 bushings will not be connected to ground. Only one bushing is, and we've designated our center one as that neutral connection. So our other connections here is we're going to take the X1 and take it over to X3. We're going to take the X1 from the center transformer and take it over to the X3.
Okay, so what do we call this wire that goes in between transformers?
Tie-in bus.
Yeah,
tie-in bus, right. Same thing now, except we're just using two. And he also explained here, this makes up my system neutral for secondary. I only need to do it one time. I don't need to do it to all three transformers. One is sufficient. Center transformer is lighting. Outside transformers are power.
And the transformer on the far right. And then our last connection, we'll take the X3, come all the way across, and we're going to connect to the X1 on the far right-hand side.
Okay, so he's cheating here. It follows the same purpose. Let's carry on and see how this goes.
Side. Okay, so now we're just going to run our hot legs down, and that's going to be on the center transformer. Your hot legs are going to be the two connections off the transformer that has your X2 bushing connected to ground, which is your neutral connection. So we've got two hot legs. They're off the transformer that's connected to the neutral. Your last connection is going to be your power leg. The way you identify your power leg is it's 1.5 coils from the neutral. So what I mean by that is we've got one full coil in this transformer, half a coil in this transformer till you get to the neutral. So this power leg right here is 1.5 coils away from our neutral. That's how you identify your power leg. Now this is important because if sometimes you can be using these connections and you need to hook up a single phase load, like to a home. Well,
okay, that's the same thing he's discussed before as far as open delta was concerned. So, you know, he cheats here a little bit. Instead of carrying two wires down, one from the left transformer down to make a connection, and one from the right transformer X1 down to make a connection, he just puts a jumper across here, which in real life is what happens. All I'm going to do here, and we don't do it in front of the transformers. Usually we carry it behind, go all the way around the back of the pole and come up, is tying the X3 and X1 bushes together, then come down with one wire. Electrically, it still works. It's still fine. One's a schematic drawing. One's a drawing that you're going to see out there in the real world. This is more real world of what you're going to be looking at. It doesn't matter if I carry two wires out of this or one, because they're copper. So one wire out is sufficient. Is everybody up to speed on that part?
Yes.
All right. Instead of carrying two wires down, one from here and one from here, and make a connection, he just makes a jumper from here to here and then carries one wire down. That's closing the delta is what he's doing right there between all three transformers with that one wire. And like I said before, out there when we build it, we're going to take a wire and we're actually going to go around the back side of the transformer, the back side of the pole, come all the way back around and put a wire in here and then one wire down.
So you're just saying to wrap that jumper around the back so it can't be seen.
Right, right.
So it's not. That's just like, so it's not ugly or what?
Well, it does look a lot cleaner. It is easier to connect, and it just keeps in visual sight. Excuse me. In visuality, it just keeps a lot of things easier to look at too. And we're going to get some actual photos here in a little bit of showing you, open delta banks and closed delta banks and Y banks in the air. So it gives you a better idea of what's going on in the real world.
If you're hooking it up to a home, you want to make sure and utilize the two hot legs and you're neutral. You don't want to hook the power leg up to the single phase load because that'll pump too much voltage into the home. And that's when you can burn up electronics like computers and TVs, things of that sort. So you always want to identify your power leg, and it's only utilized for the three-phase power. That's the only reason why you're utilizing it.
Okay, so he goes on to the rest of the business right there. Once again, let's go back to, let's escape out of this just to recover it. close that picture. You just got to watch out for whenever you're making this connection. So in the drawing, all he did here is he got rid of this one wire and he made a connection. Follow my mouse from here all the way across to X1, then came down. Electrically sound, that's 100% okay. You just have to know in all of these drawings where you put the high leg at or where you put the power leg at. That will change your voltage output. So you notice 120, 120, that's off the lighting transformer, but my power leg is attaching to A. So that's 120 times 1.7325. All right. Questions so far? Concerns? Danger, Will Robinson.
Yeah,
right, let's go to why.
The only difference is he put a jumper between the power legs. Instead of having two power legs like on the drawing, he just put a jumper from one to the other.
Correct. You are absolutely correct. Okay, why? Now we're going from a Y configuration to a Y configuration. Y primary to Y secondary. So who can remember, what do I use closed delta for in what cases? For the customer.
That's the one we just did?
No, open delta. What do we use open delta for? What kind of loads?
Open delta, three-phase.
Three-phase, but a lot of three-phase or just a little three-phase and a lot of single-phase, or think of the restaurant. Only one three-phase air conditioner, right?
Right.
Yeah, so open delta has a little bit of three-phase and a good bit of single-phase. Closed delta, where do we use it at?
A lot of three-phase.
A lot of three-phase, a lot of motor activity going on out there. Okay. Y has a purpose also. It's balanced. More of a balanced three-phase and single-phase. I need a good bit of three-phase and I need a good bit of single-phase, both at the same location. Good example of that is the college. There's a good bit of motor loads in those buildings, and there's a good bit of lighting loads, 120, 240 applications in there. So it's kind of like a 50-50 type thing. So in those cases, I'm going to use Y. A lot of your restaurants, Wendy's and McDonald's, they're all YY because they have a lot of single-phase loads inside, plus a lot of three-phase loads inside their refrigerators and their cookers and whatnot. So how many transformers are needed in a Y bank?
Like three.
Three. Okay. Open delta is the only bank that uses two. A little bit of reading we have to do here is there's a little bit of work we have to do with these transformers. I have three 120, 240 volt transformers with the windings in parallel for 120 volt operation. So let's go ahead and discuss this first. I actually have to make every single one of these transformers one secondary output voltage only. Normally, a transformer is going to come 120, 240. Well, how many different voltages can I get out of it? I just said it, 120, 240. So I can get combined. In order for me to make a Y bank, I have to convert all of these transformers to 120 only. Not a hard process. And you as linemen, we're actually going to have to do this out there in the field. And we'll show it when we get back out in the yard. There's a nut and bolt. You can take off the lid of the transformer. And I'm going to zoom in on this a good bit. Behind each one of these bushings inside of the transformer are 4 leads. On X3, there's an A lead. On X2, there's a B and C lead. And on X1, there's a D lead. It's actually stamped on the leads. If you had the lid open and you took the leads off, you can actually see a stamped in letter on the lead. To convert, and how many bushings are they using here? 1 or 2?
2.
Just 2. Okay. To convert this transformer to 120 only, it's a very simple process. I've got A, B, C, and D. That's the way it comes from the factory. I'm going to take A and C and put them on X3. I'm going to take B and D and put them on X1. So I've got AC leads here, BD leads here. Close the transformer back up.
That's
how am I going to
right
remember
now.
that? That's how
Like
it is right now. That's
like right here on this picture. It's like that.
It is. It is.
That's why there's only 2 leads coming out.
Right. And I'll zoom back out. That is what they mean by this. Transformers with windings in parallel for 120 volt operation. Remember how we, before, when we talked about how do we get 240 out of a single phase transformer? The windings are what?
Opposing directions.
Opposing directions. When I take the leads and I put AC under X3 and BD under X1, they all go one direction.
Okay.
Okay. I'm making the windings all go one direction. If I only have one direction now, can I get 240 out of the transformer?
Nah.
No, I can only get 120. At a much higher load, I got a lot of windings now, but they still all go one direction. A simple way to remember this is when you're going into the leads of the transformer, A, B, C, D, and I need to convert, well, what kind of electricity do we use? AC, DC?
AC.
AC. Well, that's how you need to wire it up. AC leads, BD leads. That has to be done to all 3 transformers. Vitally important.
And then that's just making that middle lug useless, right?
It's empty. There's no leads going to it.
Right. Okay.
Correct. Okay. There are no leads going to it, so it's not used anymore. So let's scroll back up here real quick. Voltages, primary lines and voltages, same as normal. 7200, 7200, 7200, A, B, C, all going to H1, H1, and H1. My neutral, H2, H2, and H2 are tied in. You see the connection right here?
Yeah.
Closed delta is the only bank with a floating neutral. Closed delta is the only one with a floating neutral. All right, as far as wiring secondary, this is very simplistic. I know it kind of looks strange in the drawing. You can choose either X3 or X1. For the drawing here, they've used X3 as all going to neutral. So I've got X3, going to X3, going to X3. All 3 of those connections go to neutral. Same bushing on every transformer. X1 goes to A. The first transformer. X1 goes to A, second transformer. X1 goes to B, third transformer. X2 goes to C. Take a look at your voltages right here. 120, 120, 120. That's because I converted them all to 120, right?
Yeah.
Question. Is there a lighting transformer in this bank?
Yes.
Yes.
All right. Is there a power transformer in this bank?
Yes.
Yes.
All right. Neither.
What? Okay.
Is there a transformer? Remember when my definition, is there a transformer in this bank for lighting? Is there a transformer that you could take out singularly? Let's use the center one. Would that power my house?
No.
No, it's not 120, 240. How about the other two?
No.
No, right? Is there a power transformer? Take a look at your voltages down here. Is one leg a power leg?
No.
No, they're
No,
all
there is no lighting and there is no power transformer. I mean, in this bank. The voltages are very easy. You get the individual output of every transformer, 120, 120, 120, and combined, all three are 208, 208, and 208.
tricked us.
Tricked you. Yeah, tricked you. Closed delta and open delta have lighting transformers and power transformers. Closed delta and open delta. Y does not. Now, there is something to, these are 120, 240 volt transformers that we converted to 120, but you'll notice the output right here. What's my output when I'm finished? 120,
208.
208. Does that mean all the equipment inside my business needs to be working on 208? Yes or no?
No.
No.
So I can take a 240 volt refrigerator and it would work okay.
No.
No. I'm going to have a refrigerator made for 208, correct?
Yes.
Right.
Right. Yeah. That's the way these businesses work. All of their AC units, all their, their ice boxes and their big old coolers and everything like that are on a 208 voltage. They're made for that. Okay. How you guys feeling so far?
Pretty good.
Yes.
All right, pretty decent. You're answering the stuff that you're coming up with is good. And remember, this is introductory, so we're going to get more onto it later. So let's.
So anytime you have a Y bank, you're gonna disconnect that X2, like we were talking about.
Disconnect. Yeah, that's good and sane.
Like,
you're going to take, and let me zoom in on this.
Like every time
the transformer's
going
to, right. The transformer's going to come from the factory with 3 bushings. It's going to come to the factory A, B, C, and D leads on it. You're going to convert it. AC lead over here, and they stretch. They'll move over to the bushing, and you just tighten the nut down inside the transformer, and BD over here. All right. Some companies, Santee Cooper does not. Some companies buy the transformer pre-made. It's a 2 bushing transformer. So it's already done for you. But of course, we're going to teach you the hard way. Right?
We love that.
All right. So let's go over to our chalk talk, dude. We talked about Y delta. Let's go back and look for chalk talk Y. Somebody's asleep.
Over there.
Somebody's snoring.
That's Jamie.
Jamie's out cold.
Jamie.
Jamie, wake up.
All right. Let's go YY here.
All right, we're going to talk about a YY connection. So let's start on the primary side. And the first thing we're going to do.
So a little disclaimer here. He's probably going to say it, but can anybody tell the difference in the secondary windings on the transformers? Anybody?
They only use 2 of the lugs.
Yeah. Instead of, and I like giving it separation. I like to use X3 and X1. They're using what?
X2 and X1.
X2 and X1. So under X2, they have AC, and under X1, they've got BD. Still serves the same purpose. They're just using 2 different bushings.
Okay.
Is I want to tie my H2 bushings together. Okay, once I get my H2 bushings tied together, we're going to take and we're going to tie it to ground. Common saying with a YY connection is YY you tie. And what this means is we're taking all the H2 bushings and we're tying them together, but that tie to ground. YY you tie, you're tying it to ground, the H2 bushings to ground. All right, now the second part of this is you just simply run each H1 bushing and you run a wire up to each phase. So we'll go to A phase there, center one will take the B phase, and this far right one.
Okay, just a reminder, when we have these opportunities, H1 to a phase, H1 to a phase, H1 to a phase, all H2s. That applies in all 3 banks. Use the same bushings.
This YY one is so...
Right.
And this is the connection on the primary side of a YY. H1 bushings each go to a phase, and all the H2 bushings are tied together and then tied to ground. YY you tie. All right, let's move on to the secondary side. On the secondary side, you can see that the coils, the secondary coils, they're all connected in parallel. So if you look, our X3 bushing isn't even connected. So I'm going to change colors. And we're going to put an X through the X3 bushing since we're not even going to be using it. And this is for a Y secondary connection. You only utilize 2 of the bushings. Kind of an industry standard is the X2 bushing is your neutral, and then the X1 bushing you use is your hot bushing. All right. So let's do the secondary connection now. So the first thing we want to do is we want to tie our X2 bushings together. Make that so it's actually connected. And then we're going to tie it to ground. And that's our neutral on the secondary side. X2 bushings are all tied together and then tied to ground. Now you're just simply going to run one leg down for each transformer off the X1, and these are going to be your hot legs that you actually going to have the voltage. Put an H by them since they're each hot legs. All right, so that's a secondary connection on a YY. X2 bushings are all tied together and then tied to ground, and then you've got one hot leg per transformer. And this is a YY connection. Some of the benefits of a YY connection is that all 3 transformers can share the single phase load equally, and they can be built using either a dual primary bushing like we have here, or with a single primary bushing. One of the downsides of a YY connection is if you lose one transformer, then you're just down to a single phase service until you get that transformer fixed. Go ahead and get some paper out and practice these drawings until you understand a YY.
Yeah, we'll do that later. Okay, so that's all 3 banks that you need to know about. Let me go ahead and copy this one and get it into Discord for you. So, Y bank. Great videos to watch and study right there as far as those things are concerned, and getting your drawings down and everything right. The biggest things to remember there is, what's the only bank that needs a transformer conversion?
Why?
I need to convert my Y, right? Where do I change my leads to?
Where do you change them?
Well, yeah, you can use any bushing, but what is the wiring process?
ACBD.
There you go, ACBD. So we're going to throw up one of these templates here real quick, and you're going to have to do a little work here. We're not going to make it all that simple. So you'll notice in this one, and this is one that you'll actually be doing. I'm going to do this in class. Of course, V and I are going to change the voltages around a little bit, right?
Of course.
So what's your primary voltage?
240.
2400 is phase to neutral, right?
Yeah.
And 4160 is phase to phase. So all you'll have to do is draw a line A to N, 2400, B to N, 2400, C to N, 2400. Then come over here and put in 4160 A to B, 4160 B to C, and 4160 A to C. Watch out for this question. It's on every page. Do the transformer secondary windings need to be changed? This is a Y bank.
Yes.
Yes, yes or no? To what?
AC and BD.
ACBD, perfect. Then you draw in your 3 transformers with your bushings and all that good stuff, and all your wiring down at the bottom and all that kind of stuff happens. And you guys just look like heroes in the process. Okay. Questions?
So it's got to be, the winding's got to be changed to ACBD or ABCD.
Correct. ACBD.
Gotcha.
Okay. Other things to look out for here. When you're working with your deltas, either open delta or closed delta, know where you carry your power leg to. So you notice on this one, what is my normal on my lighting side? What is my normal phase to neutral voltage?
120.
Right. So what is my power voltage? Now I'm using power transformers. For A is my power leg.
208.
208.
208. Okay, let's escape out of that. We'll get rid of that one. Now let's go to closed, and we'll use actual numbers here. Oh, this one's going to work. My secondary is 120, 240. Depending on where you draw your power leg into is where your high leg is going to go. So if they were drawing it down to A to neutral would be 120 times 1.7325. So that was pretty much a gimme. Let's take a look at, that was closed delta. Let's take a look at open delta. That's not that one. Sorry about that. Open delta. Aha. My secondary voltage is 240, 480. So wherever you draw in, and they use C for open delta as their power leg, what would C to N be? If my single phase is 240, what's my power leg voltage going to be? Go ahead and do the math.
415.8, so 416.
416, there you go. Okay, you guys are getting a good gist of this here. Right. Yes, ma'am. All right. Okay. So far, so good. All right, so let's take a look at some actuals here. Get over here, open Delta Bank. Because I do want you guys to be able to see what's happening out there in the world. Open image, new tab. And I'm not going to say anything here. What kind of three-phase bank is this?
That is
open delta.
Yeah.
Yeah.
Good signify here. How many transformers do I have?
You got two.
Two. So that's open delta. It's the only one like it. If you'll notice, which transformer is my lighting transformer, left or right?
Left.
Left, right. And my right one is my high leg transformer. This transformer, I've got two hot legs and a neutral so I can power my house with it, plus the tie-in bus that goes across. Bam. They do a little squirrely thing right here. Then out of this far side, which is hard to see in your picture, I have my high leg. So that just shows you what it is in the real world. Okay, let's try Y bank. Now, I can't spell. Now, Y bank and a closed delta bank could be a little bit harder to tell because I've got three transformers for both, right? Scroll down a little bit here.
Yeah, but you're only using two lugs on the Y.
Aha. Open image in new tab. So check this out. The center transformer is the dead giveaway for closed delta and Y. If that center transformer is not a lighting transformer, a transformer that will not power my house, this is a Y bank. Do they have a neutral in the center?
No.
Nope. Then this is a Y bank. Closed delta, to be honest with you, in overhead's a little bit harder to find. So let me see if I can find it. Closed delta bank.
So if it's a Y bank, and it's only using two lugs, will the neutral always be the lug that's missing, or do you just need to look for just the two lugs that are being used?
Medley, the lug that's missing, the lug that has nothing in it is empty anyway. There's nothing going on inside the tank. There's no connection there.
Gotcha. Okay.
So yeah. Now, your company, and I like the way you put it there, your company will be specific as to, well, we want you to use the X3 bushing as neutral and the X1 bushing as your hot leg on all three transformers. The video, what did they use? X2 and X1. So your company will tell you which ones that you need to use, but the one that's empty is not being used at all. There's no wiring going on in the transformer to be able to use it. Let me take a look at this real quick. Well, I typed in closed delta bank. I'm going to open this image up. It's a little bit dark. So I typed in closed delta. What kind of bank is this?
Why?
Why? Why? Why is it why?
Because they're only using two of the lugs.
Yeah.
Right. Even though I typed in closed delta, it gave me a Y bank picture. So let me see if I can find. Up here we go. Open image in new tab. There you go. How can I tell this is closed delta?
Because they're using all three lugs.
All three lugs in the center transformer. You got a neutral, two hot legs. Here's your tie-in bus. Going from side to side. I cannot see. Oh, there it is. Got lucky on this one. On this far bushing, you see the wire that's going around the back of the pole?
Yeah.
Yeah, that's your tie-in bus from the X1 of this transformer to the X3 of this transformer.
That's your tie-in bus?
Yeah, they put it around the back, like I told you they would. They put it around the back. instead of coming down in the diagrams that you've seen before. That's how it actually looks in the air.
Looks like a hot mess.
Yeah,
it can be. It can be, but and you know, this isn't the prettiest I've seen them, but it does give you an example of what's going on there. He's actually, what this person's doing out here is they're actually measuring amperage with that hot stick right there.
I was about to ask what that was.
Yeah, they're using a hot stick and they're just measuring amperage. Okay, so let's close that tab. All right, it is 9:37. It's been about an hour. Let's take it to about 9:50. Take a break, stretch your legs, and we will be right back. Now, if the quality is bad on this, it's because of the video itself.
This is what we call a transformer bank. We have more than one transformer on a pole and they're wired together. We use transformer banks real often for commercial businesses, places like gas stations, convenience stores, grocery stores, and on up to places like our machine shops and even our petrochemical industry and plants, oil fields. Three-phase banks, three-phase power is used when we have heavy loads. Most of the ones you see around houses have just one transformer. That'd be a single phase. That's by itself. That's for smaller amounts of power. Now there's several different types of three-phase banks and different voltages, so knowing how to wire these up properly is really important, how to handle them. It's something we go through here in training. On this particular section here, we have 5 different banks set up, and we can wire these in different configurations. Like this one, this is what we'd call a Y delta bank. Primary side or the high voltage side coming in that we'd call a Y system, anywhere from like 2400, 2400 volts up to 19,000 volts. That's what we come when we bring this high voltage in. We have to step it down. We use the transformers to bring it down. This is what we call a delta system. This was what we call a 4-wire delta. It has three phases for power. We use 2 for lighting. It's a real common type of connection. The center transformer is called our lighter. And on here we have connections. This will be a neutral or return. It's grounded, and this will be a phase. And over here is a phase. And with this, we'd commonly have like your 110 or 120 volts going to a house or a business for single phase. Over here, to have 110 or 120 volts going to a house. So this comes out, and these transformers are interconnected, and we have to be very careful how we do this because they're connected wrong. Of course, the power is not going to. We have the wrong kind of power. We're going to destroy transformers and probably our customers' property too. But on the back side of these here, we call this one our lighter transformer since it does lighting. And these 2 outside transformers, we call them our power transformers. All 3 of them provide 3-phase power, but this one does power and lighting. So knowing the specifics of wiring is one of our most important things. We use special connectors. We have aluminum wire. These are called our pin terminals. There's a special connector used for aluminum, so aluminum will hold up, doesn't fall apart. And in this end of this pin terminal, this is called a flag. These are CT lugs. These are compression connectors. We use a special tool to press that connector on, and so it'll hold a good electrical connection, bond. Okay. And we put it in this end is a tin copper, and then goes into brass. Brass and copper will work well together. They don't corrode. What we call in our Y connection is has what we call a floater. And we have a common connection in here that actually floats around or lets our load balance between transformers. The floater though carries a high voltage on it, and a floater could also be very dangerous. Some transformers, when we're switching them in to close our fuses up top here, that's what supplies power and protects the transformers. We close these fuses in, we have a phenomenon called Ferro Resonance. And Ferro Resonance will actually, it's a circulating voltage and current when we're switching these that causes a high voltage rise on these transformers. It can get 2 to 9 times our source voltage, which could be, well, think about 9 times 20,000. That'd be about 180,000 volts. That's enough to destroy these transformers and anything attached to it. So we have to be very careful about that. There's a real simple way to fix ferro resonance. What we do is, this floater is a common point between transformers, but it's not grounded. That's what makes it float. But what we do in order to fix that is we fix a small ground, just a temporary ground, and we can connect on these. What I'd normally do working on this in the field is take a insulated stick and attach this ground here. This is our case ground, all our grounds for our system. We'd bring it up here, attach it to our floater, and tighten it up. Then we go ahead and close all the fuses in, energize the transformer bank. And this would prevent ferro resonance. It doesn't allow the current voltage to circulate now. Once we're done.
Okay, so a lot of information going on there, huh?
Yeah, it looked like a slideshow.
Yeah, a lot. Not really something to super worry about right now, but we're gonna have to know about it, and you guys have to know about it in your future. So in closed delta, and that's part of the attributes of closed delta itself. Let's go over to our pictures. And go closed delta JPG. This is one of the properties of it. One, closed delta does give us the extra power that we need. Two is there's any type of imbalance of load. So let's just say here in the business or wherever we're feeding that A phase, for some reason, in that business has a lot of load consumption while B and C do not, your power leg. It's an attribute of electricity that load imbalance, the imbalance of load between one leg and another, always follows the neutral. So load imbalance will try to go and find another path or an exit path on the neutral. But we really don't want that to happen. And that's why we float the neutral. You okay?
Yeah.
Okay. So that's why we float the neutral here. We don't want it to go onto our system neutral in closed delta. We want it to go from where to where. So let's say, this transformer here is pulling a higher load. Where would that higher load go to? It's going to follow the neutral and go where?
To the bushings.
To the other two transformers. Okay. When this one starts getting overloaded, it's going to share. It's called what they call this load sharing. This transformer is going to share some of that load, and this transformer is going to share some of that load also. It's a load sharing, load balancing type of situation. Part of the drawbacks in that is what he was talking about, what they call ferro resonance, is to where if I take one of these transformers, let's say we got switches up here at the top, and I open one of the switches to these transformers, well, immediately this floating neutral is going to try, I got to pick up load for lost here. I got to pick that up real quick. And you can get really high spikes in voltage and amperage when you open a switch. So temporarily what he does is if you need to open or close switches on closed delta, you can put a temporary ground in. Excuse me. Open and close all the switches that you want to for whatever you need to do, and then take that ground back off. You're unfloating the neutral. And then when you're finished, all 3 switches are closed or all 3 switches are open. You can take and refloat it again. Wow. that wasn't me. Okay.
No,
so let's get ready.
Shoemaker at it again.
No, that wasn't me, but I'll claim mine. All right, so let's get it. We got through a good bit today. I know it's only 10 o'clock, but we've been through a good bit, and we're really caught up to the point we want to get caught up, other than stuff we can't do in the classroom. We'll sit down to stuff. We're going to go over just a couple other things here. One is, when he said, let's get a picture of one. So on 3-phase, we always needed to identify which one was the power leg, correct?
Yes.
Yeah.
Right. We don't want to, and I like the way he said in the videos, we don't want to put a power leg into a place where we should have 120 at. In your meter base or whatever you have to wire, and you'll notice these lugs right here. This is neutral. This is A, read it like an alphabet. This is A phase. This is B phase. This is the power leg. The power leg always goes on the far right-hand side. Whatever meter base you wire that has 4 wires, we'll get to the wire part in just a moment. Your power leg always goes to the far right-hand side. Your electrician, on the other hand, who was the person that knew about BOY?
I did.
Okay. He's going to wire B, O, and Y always on the right-hand side. He knows now, your electrician knows now, that the high leg is also on this side. He won't mix it up either because he's got his mark BOY far right. If you put the high leg in a 120, say that your high leg's 208, and you put that in a 120 lug, you're going to burn up people's equipment, stuff inside. High leg always goes far right. So how do I know when I pull the wire in there which one's what? Let's just try this. And we might as well go ahead and get this down. You notice in my search, I typed in what? 1 aught, that's the wire size, and what?
Quadruplex.
Quadruplex. Quadruplex stands for 4 wires total. 1 neutral, 3 hots. What would 1 aught triplex be?
3.
3 wires. 1
2
neutral,
hots.
2 hot wires. And what would 1 aught duplex be?
1 neutral, 1 hot.
All right, good deal. So let's scroll down here and see if we can find one that actually shows an actual picture here. If not, I can explain it. It's triplex, that's quadruplex. Let's see what this is looking like right here. That's blurry, I don't like it. So pretty much I'll discuss through here. Anytime that you see a yellow and a covered neutral, that's underground conductor. Anytime you see it a bare neutral like this, that's overhead conductor. There's a couple different methods that go on here. I think this one actually shows it. It does. Show open image, new tab. So I've got 1 neutral, a hot leg, and a hot leg. I don't know if you guys can see it that clearly. Do you see the ridges that are on this one conductor, the black wire?
Yeah.
Okay, that is your high leg. So when you hook this up to your transformer bank, you're going to take this to the power transformer or transformers. That is your power leg. When you go to the other end and you get ready to hook it up in the meter base, now you know what it is on the other end. It just has ridges in it. Some of your conductor companies will also put an A, a B, and a C stamped in, or, you know, with white lettering, A, B, C, and the footage on the conductor. And you'd be able to say, well, A, hot, B, hot, C, power. So that's how you discriminate from end to end. So that's one quadruplex overhead, and you just need to feel the wire. On the transformer side, I'm going to use this for my power leg. It's got ridges on it. When I go hook it up in the meter base, I'm going to hook this up in the right-hand position. That's my power leg. Make sense?
Yeah.
Okay. All right. I think we've chewed a good bit today. We bit off a good chunk, and I want you guys to take a look at both these drawings and the pictures. Study these. I mean, just take a look at them, trace them out on screen. I really don't have to burn up a printer or anything like that, but do study these drawings. Take a look at those videos today that I got posted in Discord. And I think that will pretty much cover it for today. Let me check something here real quick. Also, my recording I will post on the YouTube channel for this entire session this morning. So assignments, quizzes. Let's see what the first quiz is here. That's the three-phase simulator. So that's outside. You got to be in class for that. Quiz 1 is, let's preview it. I think this is the drawings. No, let's go ahead and let's take a look at this real quick. We might be able to do this today. How many transformers are in a closed delta bank?
2.
Closed delta.
3.
3. In a closed delta bank, in what position is the lighting transformer? Left, middle, or right?
Middle.
Middle, right. And you can always refer back to the drawings. Remember, a lighting transformer is a transformer that will power your house. How many transformers are there in a Y bank?
3.
3. There is a lighting and 2 high leg transformers in a Y bank. Uh-oh. True or false?
False.
False, yeah. There's no lighting or high leg transformers in a Y bank. They're all one single voltage. An open delta bank transformer voltage is 12240. What is the high leg voltage?
208.
Right, I need to take my 120 because I have a power leg and multiply by 1.7325. That would be 208. My Y bank single phase voltage is 277. Y bank. What is the phase to phase voltage? 277 times 1.7325 is
480.
480. In a meter base, the high leg wire goes in the far left, middle, or right lug.
Right.
Right. And here we go into the questions of what their purpose is. A Y bank is used for balanced 3-phase and single-phase load, a high 3-phase load, or a low 3-phase load.
Balanced.
Balanced. An open delta bank is used for a balanced 3-phase load, high 3-phase load, or a low 3-phase load.
High 3-phase?
No, remember, when open delta bank only has 2 transformers, I only have 1 power transformer.
Low 3-phase.
Yeah, low 3-phase. And this same thing as, like I said before, in Oliver's. Oliver's is pretty much all single phase except for 1 air conditioner. And that's the only reason why he needs 3-phase. So he's got a low 3-phase load. All the rest is high single phase. Closed delta bank is balanced, high 3-phase load, low 3-phase load.
High three phase.
Okay, good. I think you guys can get that pretty easily. If not, you can refer back to the videos or my video. Y'all agree with that?
Yes, sir.
Okay. So I will get a hold of Professor V, and we will text you on Discord when this quiz is open. Any questions for today? Guys, I know it's kind of tough. Online is not fun, but we are making progress. That's the big thing. We're not falling behind in anything. So I appreciate your participation and your concentration for those that aren't falling asleep. Okay, so we'll post that today. Study this stuff.
On question 2, that was left, right, or middle?
Right.
Go straight.
Isn't that the one that fell asleep?
Yeah.
Yeah, okay.
I was just breathing hard. I wouldn't sleep.
Yeah.
What they call it these days.
I breathe kind of heavy sometimes.
Right. And you can refer to your pictures too. You know, when you get into D2L, you know, online, I'm not going to lie to you, it's a gimme. You can go back, and if you take your time here, you can go back and look at the stuff we submitted today and go into D2L, and you can pick out all these answers. It's a gimme. Okay. All right. So I'm going to stop the recording.